Not all PTZ cameras speak the same language, and not all of them like being told exactly where to go. That's why zactrack now supports relative motion control for PTZ cameras using NDI and FreeD. Absolute control works great when a camera can handle it. You can send a pan tilt position and it snaps right into place. But some cameras struggle with that kind of constant precision, especially during live tracking. The result, a jerky motion caused by the camera's internal buffering. Relative control fixes that. Instead of absolute positions, the camera receives directional movement, a little left, a little up, now stop. It's more fluid, more forgiving, and much easier on cameras that can't keep up with the high-frequency tracking data. Whether your stream comes from a direct network connection or a converted HDMI signal, we've got you covered. To make relative camera control work, zactrack relies on two key protocols, FreeD and NDI, or when working with Sony cameras, the VSCA protocol. FreeD is a lightweight protocol originally used in broadcast and augmented reality. It sends a constant stream of information about the camera's current orientation, its pan, tilt, and zoom values. Zactrack listens to that stream in real time, so it always knows exactly where the camera is pointing. This is especially important for relative control, where zactrack needs to build each movement as an offset from the camera's current state, not a fixed coordinate. Alongside FreeD, NDI delivers the live video feed to zactrack. This is what allows you to see the camera's point of view directly inside the system. If your camera already supports NDI over a network cable, zactrack can auto-discover the feed. Just hit select in the fixture settings and choose from the available sources. If your camera only outputs HDMI, you can still use an external converter to send that signal as an NDI across your lighting network. You can control a camera and still not see a preview, and that's okay. If the NDI stream is coming from an external device and not embedded in the camera, zactrack won't automatically pair them. In those cases, just manually select the NDI stream to get the live feed working. Once your camera is patched into the show, the next step is setting up its fixture. This happens in the Edit Fixture window, where you'll assign the camera's IP address, select the NDI source, and configure control setting. If you're using a factory-tested model like the Panasonic AW-EU150, many of the core parameters, including pan and tilt ranges, are already pre-configured in the fixture type. But the IP address is assigned at the fixture level, not the type. This lets you use multiple cameras of the same model, each with its own unique connection. If your camera supports NDI, press Select next to the NDI channel field. With the fixture set to relative and uploaded to the server, it's time to launch the PTZ Camera Setup Wizard. This tool connects to the camera, verifies the NDI stream, and starts the calibration process that makes relative control possible. If everything's connected properly, you'll see Stream Loading, followed by the camera's video feed in the alignment window. This lets you visually confirm that the system is receiving both control and video data. When you start the calibration, the camera will automatically move through its entire pan and tilt range, sending orientation data back to zactrack using the FreeD stream. This step can take up to a minute to complete. Just let it run. Behind the scenes, zactrack is capturing how the camera moves, how far it can go, and how quickly it responds. Once finished, the system saves a custom motion profile for that fixture. This includes the exact range of motion and dynamic response characteristics, so tracking feels smooth, accurate, and natural. This process must be repeated for every relative camera in your show, and switching between relative and absolute control will wipe any existing calibration data, so make sure you've locked into your control mode before you begin. Once calibration is complete, zactrack generates custom motion parameters for that fixture, and you can take it a step further with the relative motion curve. This setting lives in the fixture type settings and lets you shape how the camera responds to movement. By default, zactrack uses a standard curve, but switching to a custom unlocks more control over speed, responsiveness, and fluidity, especially useful if you're fine-tuning for different camera models or tracking styles. You're defining how fast the camera accelerates as the tracker moves away from center, and how gently it slows down as it comes back. These settings map directly to the difference between the FreeD reported angle and the desired target. You can adjust min and max limits, which define when motion should start and stop, fall off, which controls how gradually the speed ramps up or down, max speed to cap out the max the camera is allowed to move. These settings help prevent overswinging or sluggish tracking behavior, letting you tailor the motion to your specific hardware and show context. Working with relative control gives you a lot of flexibility, but there are a few things to keep in mind to keep everything running smoothly. First, every relative camera needs to be calibrated individually, even if multiple fixtures share the same type. Their motion profiles are saved per fixture, not per type. That means each physical camera needs its own calibration run so zactrack can map its unique movement behavior. If you switch a fixture between absolute and relative control, zactrack will wipe any previous alignment and calibration data, so you've committed to the control method before running the setup wizard. When using relative control, overshoot is normal. if the tracker moves quickly and stops suddenly. The camera might swing a little past the target before settling. That's expected. It's a result of how directional movement is processed, and it's often more natural looking than a hard stop. And finally, if you notice jerky movement or a slow response on an absolute camera, that's likely buffering. Some cameras can't handle the rapid position updates, which is exactly why relative control is so helpful. It lowers the data load and keeps the movement smooth, even when the tracking is fast and unpredictable. Relative PTZ control opens a new level of flexibility when working with tracked cameras in zactrack, whether you're fine-tuning motion for a broadcast setup or solving jitter and lag in a live performance. This feature gives you the tools to get smooth, responsive tracking, even with cameras that don't support absolute positioning. With FreeD feeding orientation data, NDI handling video, and custom motion curves, shaping the response, you now have the control to make your cameras feel just as intentional as the rest of your show.